So order of the matrix, after that we will forward into types of matrices. Generally the matrices are two types. Okay, first rectangular matrix, another one is square matrix. Rectangular, square matrix. From the name only we can say that this will be the rectangular shaped and there will be the square shaped. Rectangular will be the rectangular shaped and square will be the square shaped. But in rectangular matrices, I already told that order of the matrix is represented by m and n. So m will be the m is the rows and n will be the columns. So let us take an example. 1 2 3 4 5 6 7 8 3 4 2 1. This is one of the matrix. How we can say that this matrix is either rectangular matrix or square matrix? How we can say? I already told that m and n. So how many m and n we have to know that? How many m is present here? How many rows is present here? First row, second row, third row. Means 3 rows. How many columns are present here? 1 2 3 4. So there will be 3 rows, there will be 4 columns. If you see in the question paper, if you see first, when the m is not equal to n, at that time there will be rectangular matrix. So rows is not equal to the columns. Row will be not equal to the columns. Here 3 rows and 4 columns will be there. So 3 is not equal to 4. So this is the example of rectangular matrices. So rectangular matrix is already known. Then we have to move forward to square matrices. What is square matrices? This will be the square set I already told before. So square matrices, when let's take an example like 1 2 3 4 5 6 7 8 and 9. This is the matrices. This is the m and n. First we have to know that how many rows and how many columns will be present. 1 2 3 1 2 3. So there will be 3 rows. 1 2 3. There will be 3 columns. So 3 by 3 matrix. So order will be 3 by 3 matrix. I already told that when m is not equal to n, there will be example of rectangular matrices. So here m is equal to n. So 3 by 3. 3 is equal to 3. M is equal to n. At that point of view, the matrices will be square matrices. Okay. So 3 by 3 will be this is the example of square matrices. This is the example of rectangular matrices. So just revise: rectangular, square. M is not equal to n. Here m is equal to n. Just remember. Rectangular matrices and square matrices. So again we can be divided by matrices into 3 types. Okay, 3 types. One is row matrices, column matrices, null matrices. This null matrices is important. This is the bits is maximum times is coming. Row matrices, column matrices and null matrices. Row matrices, what is row matrices? Row matrices means there will be only one row is present. Row means horizontal line. So all the letters will be present in one row. Like take example 1 2 3. Okay, 1 2 3 means there is only one row is present. So there will be, this is the row matrix. Okay. Column matrix. Column matrix means, what is column? This is the vertical lines. Vertical lines I told 1 2 3. Okay, this is the vertical lines means there is column matrices. Vertical line is the column, horizontal line is the row, vertical line is the column. So this is the columns. Vertical line is the columns. This is the column matrices. One column is present, that is column matrices. One row is present, that is row matrices. Okay. Null matrices. What is null matrices? Null matrices. Null matrices means when there is a matrix, when there is a all the letters of the matrix has zero elements. Okay, zero elements is present. All the matrices of the all the elements of the matrices is going to be zero, 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 zero. First row zero, second row zero. Okay, first column also zero, second column is also zero. So this is the row matrices. Okay, what is the order of the row matrices? Zero order, because one by one. One by one. Okay, one row is one column, one row one column is present, so there is be null matrices is all the elements will be zero. This is the null matrices. Again we can divide the matrices into different types, like one, upper triangular matrix. Second, lower triangular matrix. Three, diagonal matrix. Okay, scalar matrix. Five, identity matrix. Okay, upper triangular, lower triangular, diagonal, scalar, identity. Upper triangular. What you know? How we can say about this upper triangular matrix? Let's take an example of upper triangular matrix. 1, 2, 3, 0, 4, 5, 0, 0, 6. Okay. So it will form like an upper triangle. Upper triangle means upper position. There will be letter will be there, like 1, 2, 3, 4, 5, 6, like will be present, like 7, 8, 9, and the lower surface all will be 0. If you see in this matrices, all the above portions are filled with letters, and all the lower portion filled with the 0. This is the upper triangular matrix. Similarly, lower triangle matrix, lower triangle matrix, what will happen? The 2, 3, 5 portion will be filled with 0, and 0, 0, 5 portion filled with 1, 2, 3, 5. 0, 0. Okay, 2, 4, 0, 5, 6, 7. Okay, this is the example of lower triangular matrices. Upper portion will be the 0 portion, and lower portion will be the filled with letters. Okay. Okay. What is the diagonal matrix? Diagonal matrix, diagonal. So all the letters will be present in the diagonal portion. Okay. Let's take an example. 1, 0, 0. Okay. 0, 2, 3, 0, 2, 0, 0, 0, 0, 5. Okay. 0, 0, 5. This is the diagonal portion. All the elements will be present, and all the rest of the elements will be 0. So this is the diagonal matrix. So what is scalar matrices? Scalar matrices means all the elements. The difference between scalar and diagonal matrices is, in the diagonal matrices the diagonal elements may be of different types. In the scalar matrices the diagonal elements will be the same, like 4, 0, 0, 0, 4, 0, 0, 0, 4. All the elements of the diagrams, like upper diagonal or maybe the lower diagonals. We can say the upper diagonal, the one diagonal is the second diagonals. Okay, whatever the diagonals will be, the diagonals elements will be same in case of scalar matrices, but in case of diagonal matrices, this is all the elements may be different types. So what we can say, all the scalar matrices will be diagonal, but all the diagonal matrices will not be scalar. Okay, identity matrix. Identity. This will be the 1. Okay, identity matrix means all the elements of the diagonal will be 1. So 1 0 0 0 1 0 0 0 1. This is the diagonal elements, all the will be 1. Okay, all the diagonals will be 1, and this is the identity matrix. So okay, like this is the 3 by 3 matrix because this is the 3 rows and 3 columns will be there. Like we can say 1 and 0 0 and 1. 2 by 2 matrix, this is the 2 columns will be present and 2 rows will be present. So this is also a identity matrix.